All right, welcome to just a little bit more work on polls and margin of error. And the first thing we're going to do is find the margin of error for a survey with a given sample size. So remember, to find this, we want to take 1 over the square root of the sample size. So in number 1, we would take 1 over the square root of 958, which would give us 0.032, which is 3.2%. Go ahead and try the other three, and then come back, check your answers, make sure you're getting the right decimals and percents. So in number 2, we take 1 over the square root of 4,500, and you get 0.015, which is 1.5%. Notice from 1 to 2, our sample size got bigger, our margin of error went down. So the bigger the sample, the smaller the margin of error. In number 3, our sample size is smaller than the sample in number 2, and therefore our margin of error should be bigger. And we would end up with 0.028, which is 2.8%. And that should make sense. 1250 is between our sample sizes of 1 and 2, and our margin of error was between the margin of error for those. And number 4, I have a small, right? So if you think about 1 over the square root of 55, 55 is smaller than 958. So my margin of error should be bigger than 3.2 because they're, kind of opposite. And I get 0.135, which is 13.5%. That's a large margin of error, just in case you wondered. All right, next page. Explain what the margin of error means. Well, there's a lot of different words for this. The margin of error is basically, it's the allowable difference from the estimate. So allowable difference from the estimate. It's where we talk about the plus or minus. When you fill up your tires of your car with air, you want to be within a certain PSI pressure, right? Just talked about this today with my car. So you would say, maybe 33 PSI plus or minus 2 or something like that. And if you get outside of that, that's where your little light comes on in your car, right? Okay. 6, we've already talked about. As the sample size increases, so if you talk to more and more people, your data becomes more accurate. As the sample size increases, that should be an S, not a D. Nobody's paying attention anyway. So as sample size increases, your margin of error decreases, and vice versa. If your sample size gets smaller, your margin of error gets bigger. All right, let's do some problems. An online poll of 1,324 high school students found that 84% think that cell phones should be allowed in class. So population, recall that population implies all. Population is everybody you can pull from. So in this case, we were talking about high school students. So my population would be all high school students, all of them. Well, it's impossible to talk to all of them, right? It's impossible. So that's why we deal with samples. Samples deal with the numbers. So 1,324 high school students would be my sample. We just practiced margin of error. So 1 over the square root of n. So I take 1 over the square root of 1,324, which gives me a 0.027 or 2.7% for my margin of error. I use that for my confidence interval. And recall that the 84% is what I'm going to use as my estimate. So for my confidence interval, that's a 2. I need 84%. And we just found our margin of error. So to find my interval, I will subtract going to the left, I add the margin of error going to the right, and my 95% confidence interval is 81.3% to 86.7%. And I can use that in my meaningful sentence in part E. So, going back to the concept I talked about in other videos, like Mad Libs. We are 95% confident that, and then at my interval, 81.3% to 86.7% of who? Of high school students. What are they doing? Think cell phones should be allowed in class. You're always going to be 95% confident because it's the only interval we're dealing with. So you're 95% confident that your interval, 81.3% to 86.7% of high school students, you got to talk about who you're talking about, and think that cell phones should be allowed in class. All right. Next page. Next number 8. If you haven't been stopping this to try them on your own first, I want you to do that now because this is a good one to just kind of see where you're at. A poll of 540 college students found 93% said colleges should do away with final exams. Well, everybody's got an opinion. All right, population. Remember, population talks about all. And who are we talking about? College studentes. The sample deals with numbers. 540 college students. Margin of error, 1 over the square root of n. What is n? N is your sample size, and in this case, it's 540. So we end up with a 4.3%. Oh, I missed the decimal form, sorry. 0.043. We use that margin of error for our confidence interval. So my estimate was 93%. To the left, I subtract my 4.3%, and to the right, I add 4.3%. And when I do that, I get 88.7% and 97.3%. There's my confidence interval. So if I want to use that in a meaningful sentence, once again, you go back to your Mad Libs. How do you start? We are 95% confident that 88.7% to 97.3% of who? Of college students. What are they doing? Think colleges should do away with final exams. And you notice how I don't make any of this up. I pull this stuff straight from the problem. College students think colleges should do away with final exams. Now, questions F and G are total opinion. Do you agree or disagree with this poll? Well, if you took a poll of students at Ivy Tech in Warsaw, do you think that between 88.7% and 97.3% of them would say, yes, do away with final exams? I would say probably. I don't know who likes final exams. I mean, I take classes. I hate final exams. So I can imagine that the majority of people would say that they would want to get away with this. But should colleges be making decisions based on the results of this poll? I'm going to go with no. Colleges are in the best interest of serving students and helping them learn. Letting the students, decide. Not that all students would make bad decisions, but I can't think that the curriculum maybe would be as difficult if students were deciding. That's just a personal opinion. I would definitely make my life easier, right? Who wouldn't? It's crazy. All right, well, hey, there's margin of error. Hope you enjoyed it. Have a good one.